In this video, I will talk about the second group of aliphatic hydrocarbons, which is alkenes. But now first, let's just have a review on the alkanes that we discussed before in previous videos. So let's just have this shape or this stick structure of hydrocarbons. This is an alkane, right? So first, what do I want to ask you is how many carbons do we have here? Just 1, 2, 3, 4, 5, 6. As you can see, there's no branches here. There's no substituents here. So we just can name this structure directly. So we have 3 carbons. So the prefix will be hexa, and we know that this is an alkane group, so it will be hexane, of course. Alright, so and now what I'm gonna discuss with you is what's gonna happen if we have a double bond in somewhere in this chain. So what if I have a double bond here? So this structure gonna be a hexane, sorry, a hexene, because this will be a group of alkenes, and what makes alkene special that it has a double bond and somewhere in this structure. So let's just have a name to this structure with a double bond. So let me just write it here. So it will be a hexene. But there is one more thing. This double bond can be here, or here, also here, or here. There is many different possible positions for this double bond. So what I need to do now is to focus on the position of this double bond. So what can I do? Of course, to give a position, to give a bond a position, what I need to do in hydrocarbons is to number the chain and then find where is this chain in these numbers. So first let's just number this chain, but try to take the lowest number for this bond, the lowest possible number for this bond. So if we choose from the left side, we know that the number for this double bond will reach to 4. Let's just see it. 1, 2, 3, 4, 5, 6. So it will be between 4 and 5. But what if we do on the opposite side? 1, 2, 3, 4, 5, 6. So it will be between 2 and 3. So as you can see now, this number is between 2 and 3, and what I need to do is to choose the lowest number of them. So it will be 2, then dash hexene. Now let's just make things more complicated than just now. So let's just have another example. So in this example, the first thing that I need to do is to find the long chain. So the longest chain is this. So this should be the longest chain here. Because if you can see here, if you notice that we have 1, 2, 3, 4, 5, 6 carbons. So this is the longest chain here. So what next that I should do? The next step is to number this chain, because as you can see we have here a branch here, a substituent, and also we have a double bond here, which is alkene, of course. So from which side do I need to count the numbers? So what it depends on? It depends on the double bond. So I need to take the side, I need to number the side, I need to start counting from the side which give me the lowest number possible for the double bond. So let's just suppose that it is from the right side. So if we count from the right side, it should be 1, 2, 3, 4, 5, 6. Now let's just have it from the opposite side. It will be 1, 2, 3, 4, 5, 6. As you can see here that we have from the both ways, the double bond will be between 3 and 4. So what's else that I can do? Now if the both sides are the same, so I need to choose the side depending on the branch. So this branch here, I need to see what is the minimum number for this. So if I see from the right side, it will be the number 4, but from the left side it will be counting the number 3. So the right side here will be from the left side. So this will be wrong. I will not use this. Alright, so now let's just name this structure. So what I need to do first is to name this branch. So this branch is a methyl because it has only one carbon. So this branch is a methyl, CH3. Alright, so it will be a methyl. Alright, so let's just write the number. So it is in 3-methyl. And now what is left to me is to write the group name of this shape with numbering the position of this double bond. So as I know, this double bond is between 3 and 4, and what I need to choose is the lowest number of them. So it will be 3 dash as I know that this chain is hexene, so I will need to use the prefix hex and then the alkene group, which is ENE. So it will be hexene. So the full name is 3-methyl-3-hexene. Now we'll just have another example. But in this example I will have more than a double bond. So let's just see how can we name this shape. So now we'll just get over to this example. The first thing what I need to do is to find the longest route or the longest chain. So as it is clear to you, the longest chain will be like this, which is consists of how many carbons? 1, 2, 3, 4, 5, 6. It is also 6. So the second thing what I need to do is to find the branches. So this is a branch. So we have only one branch. So the third thing is to number the chain. So from which side do I need to number this chain? So let's just number the chain, and also as you can see we have more than one double bond here. There is here one double bond and another also here. So let's just let me just clear this. So let's just count or number the chain from the upside here. So it will be 1, 2, 3, 4, 5, 6. As you can see here, this chain will get number 1 because it's between 1 and 2, and we always take the lowest number, so it will be 1. And this chain will be between 4 and 5, and we always take the lowest number, so it will be 4. Now we'll just try to number this chain from the opposite side, and let's just see what the numbers that we will get. So I'll just say 1, 2, 3, 4, 5, and 6. So the number that we will get here, this double bond is between 5 and 6, so we will take the lowest number, it will be 5. And this is between 2 and 3, so we will take the lowest number, which is 2. So now to summarize, what do I need to take? The only thing that I need to do is to take the sum of every number that we get from every side. So from the upside, the numbers that we get is 1 plus 4. This is equals to 5, and this is from upside. But from downside, the numbers that we get is 2 plus 5, which is equals to 7. So this is from downside. So the way that we'll get is from upside, because we got the lowest possible number. So let's just count from upside. So first what I need to do is to see where is my branch, where is my substituent. So as we say that we count the numbers from upside, so it will be like this: 1, 2, 3, 4, 5, 6. So now my branch will be on number 4. So it will be, as I know that this is methyl, I don't need to remember this every time I look at this, so just I need to recognize it at first. So I know that this is in number 4, and this is also methyl. Then after that, I know that we have 2 double bonds, and each double bond has a number, of course. So the numbers that I said is 1 and 4, right? So I will just write 1 and 4. Then after that I will write dash. Then I know that this chain is consists of 1, 2, 3, 4, 5, 6 carbons. So it will be of course hex. As I know that it should be hexene, right? Hexene. But because we have two double bonds here, I should write another prefix, which we call it by di. So it will be hexadiene. Hexadiene. Alright? If you need to remember one more, the prefixes for if we have more than one group. So this is our prefixes. Mono, this represent from 1. Di represent for 2. Then we have tri represent for 3. Then we have tetra, this represent for 4. Then we have penta or pent, and this represent for 5, and so on. And now I need to discuss with you some cycloalkenes shapes, which are very important in alkenes groups. So these are the cycloalkenes shapes, which I need to discuss now with you. So first, let's just start with this shape. In this shape, you can see a structure is consist of about 4 carbons, 1, 2, 3, 4, and there is a double bond here which refer to an alkene group. So what I need to do now is to see how many carbons do I have here, which I already have it, which is 4 carbons, so it will be the prefix but. And the second thing is, where is this double bond? So there's a fancy question here. Is numbering this double bond is important here or not? So if we just number it, if we number this chain, so it will be like this: 1, 2, 3, 4. So is this important or not? If you can see here, the double bond here is between 2 and 1, and we always will choose the lowest number, and it will be 1. So let's just suppose that this double bond is not here. This double bond, we removed it from here and just moved it to here. So what is the changes will be? So I easily will change the counting number. I will cancel this. I will easily just count the numbers from here to here. It will be like this: 1, 2, 3, 4. Right? So, and as you can see here, the double bond will be between 1 and 2, and then I will choose, of course, the lowest number, and it will be again 1. So as for this reason, I can do the same way with this side and this side. So there's no difference wherever I put this double bond, the numbering will be the same and the position of the double bond will be the same. So it's not important for me to count or to number this structure. So I'll just leave it as it is. Alright. So what I need to say now, this shape is a cyclo shape. So I need to say cyclo. Then I know that this is a shape of 4 carbons and it's also an alkene, so it will be butene. Cyclobutene. Alright, so that's it. Now let's just move to the second example. So in this example, what I need to see first, the main shape here. The main shape is this cyclo shape. This whole cyclo shape is the main shape. Alright, so where is my branch? Where is my substituent? So this is my substituent. Alright, so now what I need to do is to number this main shape, this cyclo shape. Alright, so what should I do now? Should I counter it? Should I number it from left side to right side? It means like clockwise direction, like this, or like this, counterclockwise direction. So let's just see what should we know. If we counter it clockwise direction, so it will be like this. This is 1, 2, 3, 4. Alright, so my double bond here will be between 2 and 1, so we always take the lowest number, so it will be 1. But if you take the numbers from the opposite direction, like counterclockwise direction, so it will be like this: 1, 2, 3, 4. And as you can see now, the double bond is between 1 and 4, and now we will choose the lowest possible number, right? And it will be 1. So fortunately, this is very funny that we got the same results from the both sides. So yeah, you can choose any direction of the both sides. So let's just choose this direction, which is clockwise direction. 1, 2, 3, 4. So what I need to do now is to see or to look out to the branch. So this branch consists of 3 carbons, which is C3H7, right? Because this is an alkyl group, so it will be C3H7, which is probyle. Alright, so now what I need to do is to name this whole structure. So first I want just to see where is this branch. So it is in number 1, so it will be 1, then dash, then probyle, then another dash, then the double bond is between 2 and 1, so we'll take the minimum number, and it is 1. And also this whole shape, we call it by a cyclo shape, so it is a cycle, of course. And also it is consist of 4 carbon number, and it has a double bond, so it will be a butene. Alright, so this is the name of this structure, and that's it.